Salmon swim on highway bridges. Salmon swim on concrete walkways and in community parks. Salmon swim on walls in our homes, in poetry, song, and story. Salmon swim through the air and by our businesses, in schools and parades. And sometimes salmon swim in cold water streams, in deep pools and undercut banks, shaded by trees. Salmon infuse the Pacific Northwest. We see them every day, identify with them, celebrate them, see them off to sea, and welcome them home. Yet what do they mean to us? Salmon are a keystone species and critical member of the biotic community. Their impact on an ecosystem is disproportionate as compared with their biomass. Their absence or presence is an indicator of the health of a watershed.
To the ecosystem, streams are acyclic energy systems. Flow through energy systems. Salmon bring that energy back from the ocean. They find that a good, healthy stream that has salmon in it is much healthier than a stream that doesn't have it. You have a lot more phosphates, nitrates, and other nutrients and chemicals that the salmon bring back.
These anadromous fish live a transformative life. They will spend their first few months in fresh water. Juvenile fish then swim out to sea, their physiology changing to uptake oxygen from salt water in the ocean, where they will spend several years living and growing. In the last part of their life, salmon change again, returning to their natal freshwater streams to spawn and shortly thereafter die. As they flourish in their transformations, their lives and deaths contribute to the prosperity and success of other species. In the ocean and estuaries, salmon feed orcas and seals. In streams, they feed bears, bald eagles, and herons. They also feed the forest.
They even done studies. They can tell the difference between ocean phosphates and land-produced phosphates, and they found ocean phosphates in deer and elk. It's not that deer and elk are eating the salmon, but they're eating the vegetation along the stream that absorbed those nutrients from the dead, dying salmon. So it's very important to have a good, healthy salmon run that comes back for ecological purposes.
For thousands of years in the Northwest, salmon reflected the cycle of life, served as a staple food and as a source of story and ceremony for Native Americans along the Pacific coast. Salmon thrived in their wild environs, relying on delicately balanced stream and ocean conditions for their transformative journey through life. With the westward migration of white settlers into the Pacific Northwest and into the Seattle region in the 1850s, the giant trees that shaded salmon streams spawned an economic boom in the form of the logging industry. With the arrival of a transcontinental railroad in the late 1800s, the number of humans grew, as did the economic expansion of lumber and mining operations, shipping and shipbuilding, and fisheries. As the trappings of industry grew and thrived, the habitat for salmon began to shrink, and salmon populations began to wither. Salmon require cold, clear water with a specific chemical balance. But toxins now tainted that water. Spawning salmon and small fry require specific water levels and gravel beds in their streams. But dams built for hydroelectric power and diversions for agricultural irrigation stopped the flow or flooded streams, disrupted spawning, and even stopped their passage from natal stream to the ocean and back again.
Basically, there was no more salmon left here, so they rebuilt the hatchery in the 30s. They restocked Chinook and Coho at this hatchery from the Green River, so it's basically the same stock of fish.
In recognition of the importance of salmon to both the biotic community and to people in the region, the Issaquah Salmon Hatchery was constructed in the 1930s to bring back the salmon to Issaquah Creek, salmon that had been eradicated by overfishing and habitat destruction. Operated by the Washington State Department of Fish and Wildlife, the hatchery works to this day to rehabilitate salmon populations amidst continued challenges to their success. The Issaquah hatchery has inserted itself into the spawning process of Coho and Chinook salmon. Each fall, salmon return from the ocean through Puget Sound, the Ballard Locks, Lake Washington, and Lake Sammamish before finally arriving at Issaquah Creek. A low barrier, or weir, is raised where the creek meets the hatchery, preventing the salmon from continuing upstream to spawn naturally and soon thereafter expire. Instead, they are diverted into a fish ladder that leads to holding ponds where the work of the hatchery begins. Spawning and rearing salmon is a months-long process that begins in the holding ponds. Crews of volunteers assist fish and wildlife staff in harvesting and fertilizing eggs by the hundreds of thousands. Wild salmon are separated out during the process, their eggs and milk distributed as widely as possible to ensure the best genetic diversity. While the spawning appears a somewhat gruesome endeavor, the hatchery process gives salmon their best chance of survival in the initial stages of their lives.
We get a fairly good return on our Chinook, about 1%, which is pretty good when you consider they're released and as three-month wonders. They're only about 3 inches long, and so they're subjected to a lot more predation.
Hatchery staff nurse the salmon with every means at their disposal, taking care that each and every egg, aleven and small fry salmon, succeed by removing risks they would naturally encounter in the wild.
Typical hatchery spawning for Chinook, it's a kill process, where if the fish are ripe, we kill them, split the hens open, the eggs fall in the bucket. We do 5 hens per bucket, and we'll do what I call a matrix spawning, where you take those 5 hens with their group of eggs, and you pour them into smaller buckets, mixed up, and then you have a cup of sperm from one male for each one of those 1-gallon buckets. And you pour it into that, and our geneticists figured that that's one of the quickest, easiest ways to get the most genetic diversity you can get, so we're not limiting the gene pool. And then we put them in the incubation trays. There's a 1-hour period where the eggs are water hardening. That's when the eggs come out of the female, and the eggs are really soft and pliable. It takes about an hour for them to water harden, process where the eggs actually start feeling like a BB. So that process, we have them in iodine, which kills any bacteria or fungus on the outside of the egg while they're water hardening. Then we turn on the water on incubators, and they're in for the rest of the duration until they're ready to be fed.
Towards the end of their hatchery lives, small fry are transferred from their incubating trays to raceways, and then fed until they grow to release size. Before the release, they are marked by the removal of their adipose fin to indicate to fishermen and hatchery staff their ancestry as a hatchery-raised salmon. The salmon then live their adult lives at sea, and in a few years will return home to Issaquah to begin the life cycle again. While the Issaquah hatchery and others like it around the region labor to improve the chances of salmon for a Pacific Northwest culture that admires and venerates them, salmon face nearly insurmountable obstacles to their success. These sensitive creatures are constantly threatened by continued destruction of their habitat and lack of habitat restoration, pollutants that enter streams and lakes, barriers that interfere or stop their great journeys. Without the efforts of hatcheries to cultivate them, wild salmon would once again disappear from Issaquah Creek and possibly the Pacific Northwest altogether.
In this region, the biggest obstacle is humans. We develop along their streams with houses. We put obstacles in the way, such as the Ballard locks. That's a good example of what is an obstacle that prevents the salmon from escaping the seals. Everyone blames the seals, but seals are just taking advantage of the situation. But all those things add up to the destruction of the salmon.
As much as our culture admires them, salmon may be seen as our competitors. To restore wild salmon requires personal awareness and sacrifice, distribution of public funds that are already stretched thin, regulations that might impinge on private business, and restoration of habitat now in human use. Salmon may also be seen as participating members of the biotic community. Their restoration can reshape and secure economies, restore and revitalize stream and forest ecologies, help with the recovery of other species, solidify our environmental values, delight our aesthetic senses, and give us inspiration for new stories. These differing perspectives may not be mutually exclusive, but they are certainly in conflict, a conflict that makes the future of salmon quite uncertain. Will that future be as a cultural artifact, a remembrance and celebration of a rich and storied past? Or will salmon be a living symbol, illustrating the bond between our culture and nature, and exemplifying an ethic that, as Aldo Leopold said, preserves the integrity, stability, and beauty of the biotic community, a community of which we are all a part.